Greetings to all the viewers of the channel. Today we will look at a useful household gadget, the electric fly swatter. This is a device for killing flying pests by means of electric shock, in other words, an electric chair for insects. And today we will try to understand how effective it is, whether it's worth buying at all, and, of course, we will study its operation and discuss the circuit. I remind you that you can find the link to the full article in the description, along with the link to the product. I bought this gadget last summer, and as you can see, it's still working, which is already a good sign. At that time, the racket cost about $10. The appearance is quite decent. The plastic is cheap, but resistant to mechanical damage and impacts. We have two outer grids with a wide spacing and one grid in the middle. The outer grids essentially act as the ground, while the one in the middle is the positive. When an insect gets between them, it closes the circuit, causing a current to flow through the creature's body. High voltage. The racket is powered by batteries and has a built-in charging system from a 220-volt outlet. During charging, the corresponding indicator lights up. To activate the fly swatter, you need to set the switch to the on position and press the button. The device will turn on, as indicated by the second indicator LED. When the button is released, the system turns off, but high voltage remains on the grid for some time due to the storage capacitor in the high voltage circuit. Well, now let's open up the racket to study the internals in detail. Inside, we have a small circuit board and a power source consisting of two nickel-cadmium batteries connected in series. That is, the total voltage of the power source is about. I measured the battery capacity separately. Approximately 200 mAh. Nothing more was to be expected. The fact that this device uses rechargeable batteries is already a good thing, although nickel-cadmium is from the century before last. Let's return to the circuit board, which consists of three main parts: the battery charging circuit, the generator, and the step-up transformer with a high-voltage voltage multiplier. The charging circuit is implemented based on a transformerless power supply with a current-limiting capacitor. It works in a simple way. The capacitor limits the current, then the alternating voltage is rectified to direct current, and the battery is connected directly to the diode rectifier. It should also be noted that in this circuit, the battery serves as both the load for the bridge and the stabilizing element simultaneously. The charging current will depend on the capacitance of the dropping capacitor, which is about 70 mA per 1 F of capacitance. Such a circuit will charge the battery indefinitely as long as the device is connected to the network. But there's no need to worry about the batteries, as the charging current is negligibly small. Regarding the red LED as a charge indicator. In reality, it indicates the presence of mains voltage, not the charging process. The boost converter circuit is simple. A standard self-oscillator on a single transistor. The output voltage from the secondary winding of the transformer is about 250 volts if the battery is fully charged. And this is the waveform at the transistor's collector. Maybe someone will find it interesting. The operating frequency of the self-oscillator is about 17 kHz. Let's move on. The high voltage section. A voltage multiplier built on two capacitors with a capacitance of 2200 pF and pulse diodes of the FR107 type. A large capacity film capacitor is installed at the output of the multiplier. Essentially, the multiplier charges the specified capacitor, and it's the capacitance of this capacitor that strikes the insects. This increases the overall efficiency of the circuit. The specified capacitor has a capacitance of 22 NF and a voltage of 2 kV. The voltage on the grid itself, approximately around 1000 V. This is enough to create a small air breakdown. This is necessary for the effective striking of the target. The latter will receive an electric shock even when at a small distance from the central grid. Regarding operational safety, it's generally not dangerous for humans. If you touch the grid, nothing will happen. However, if you stick your finger between the grids, you'll get quite a shock. Naturally, it's not lethal. How effective is such a racket? If an insect gets between the grids, receives an electric shock, and manages to slip away, it will be paralyzed and most likely end up on the floor. If no action is taken, the creature might get up and fly away as if nothing happened, although it will most likely never reproduce. In the case where an insect gets stuck between the grids, which has about a 50% chance, it faces the fate of Joan of Arc. It will burn alive if the racket is not turned off for a few seconds, and it will most likely never be able to recover its strength. Well, in general, that's all I wanted to say. I will add that the racket works exclusively on all flying and crawling creatures, and if desired, even on two-legged ones. Friends, I remind you that you can find the link to the product in the description, along with a full article with detailed tests. Don't forget to rate the video with your like and share it with friends. And with that, I say goodbye. Until next time, bye.